Day 3 is about conditionals and test operators. This is exactly the kind of bash security topic that looks easy in a demo and gets messy the second it lands on a real Linux host. The shell is already there, which is why engineers reach for it under pressure, but that convenience only helps if the script is explicit about what it is checking and what evidence it found. My goal is never a flashy one-liner. It is a script another engineer can trust. The operational problem is basic shell decisions that become security problems once they hit a real Linux box. That means the script has to handle real files /etc., live logs /var/log, service state, and commands that may behave differently across distributions. If the script reads SSH settings, I want it to say which file it parsed. If it checks a running service, I want to see the systemctl, journalctl, ss, find, grep, or stat output that supported the conclusion. That level of specificity is what makes the result auditable later. My baseline never changes, #usr/bin/env set EUO pipe fail, narrow scope, and output that tells the next engineer what was checked and what was not. I also try to keep the bash itself thin. The shell should handle control flow, guardrails, and reporting. Native Linux tools should provide the underlying facts. That keeps the logic visible and makes the result easier to defend later. If the script needs something optional, I want it to fail with a clear warning instead of pretending the host passed. For this topic, I want evidence from quoted variables, predictable paths, and native Linux tools /etc and /var/log. Bash is great here because it can glue those host tools together without introducing another runtime or a bulky framework. That matters during audits, hardening work, or incident response when you need something small, transparent, and easy to rerun on the same host. I would much rather have a disciplined shell script than a bigger tool nobody understands under pressure. The common failure is optimism. A script assumes a path exists, suppresses an important error, or keeps going after a command proved nothing. Suddenly you have output, but you do not have proof. In security work that is worse than a clear warning, because it creates false confidence and hides the fact that the check never actually verified the control. This is also why I avoid unnecessary cleverness in shell parsing. If the output format is hard to explain, it is hard to trust. The bar I care about is small bash routines with strict defaults and readable output. If the script produces a stable answer another engineer can replay later, it is useful. If it only works on the author's box, it is not production ready. Good bash security tooling is boring in the best possible way: obvious paths, strict defaults, clear evidence, and conclusions that can survive a ticket review, a post-mortem, or an incident bridge. That is the mindset I want you to carry into every bash security script you keep. My final check is whether the script would still make sense to someone who did not write it. Could they see what host artifact was trusted, which command produced the evidence, and what would make the result inconclusive? If the answer is yes, the shell routine is probably ready. If the answer is no, it needs another pass before it belongs in a production security toolkit. I also encourage you to think about output retention. If the script is useful, someone will eventually want to compare today's result with yesterday's. That is why I like predictable file names, straightforward stout, and summaries that can be diffed or dropped into an incident note. Bash gets stronger the moment you treat the output as evidence instead of disposable terminal noise. That is really the whole lesson. Use the shell where it has leverage, keep the scope narrow, show the Linux artifact you trusted, and never hide uncertainty. Do that consistently and you end up with bash security scripts that are fast enough for operations, disciplined enough for audits, and calm enough to trust during a messy incident. That reliability is the real payoff. It is what keeps a shell script useful after the demo is over.